Is for me to know and for you to find out. Let's pray. God, we thank you for this time. I pray that you will bless our chemistry class, help us to actually make progress. In Jesus' name, amen. All right, so today we are talking about answering those horrible homework problems I assigned. They just won't go away. We're still on that. Like, that's bad. That's like a really, really bad homework assignment. Where's the kid? You replace the kid? Okay. All right, 21.
Yes, we got a better risk of feeling going on.
Sodium monofluorophosphate, Na2PO3F, which they give the molar mass as 144 grams per mole. This is a fluoride component in some water toothpaste. No sunglasses inside. Thank you, sir. What is the molality of the solution? So molality is given as moles. I don't like you two sitting together. Moles per liter. Moles per moles per
Moles per kilogram.
moles per kilogram. All right, we're going to do some reseating. You here.
Can I say something else?
There.
It's a new adventure.
You there.
Wait.
You
Please don't say you.
switch with Ryan.
Me and Bobby are good.
All right, awesome. Cool. Molality, moles per kilogram. Okay? Molarity, moles per liter. Molality, moles per kilogram. Right? That's right.
Wait, Mr. Butt. I'm sick.
You're sitting there.
My brain is
Good luck. All right, so 1.85 kilograms of water and 1 mole of sodium saccharide.
Jeez, Brian.
You've never sat next to Ryan, have you? It's really a treat. You know enjoy it.
We're getting a lot of things.
Okay, R mix, what's the molality? Okay. So, how do we find the molality? Let's just do moles per kilogram. Are we surprised? No. Okay, then they make it a little bit harder, as always. I'm so excited to be done with this chapter, because then we can have a test on it.
Oh.
Okay,
Bless you.
That was so cute.
Shut up.
next.
Sorry,
Oh my
it came out of me. I'm sorry.
It's gone. It's gone. We lost it.
You just hold my Caesar.
Okay, now we're mixing these two. Molality is what, Grace?
Who is masculine?
You didn't do that. God bless you.
Oh,
Bless you. Oh,
may God bless thee.
And keep you, make his face shine upon you.
Lord bless you.
Okay, so we have grams of that and grams of that. We need moles per kilogram. Do we have moles per kilogram? No. How do we find moles per kilogram? We need moles of this, and we need kilograms of that. How do I get kilograms? Well, that's 0.125. That's easy. How do I get moles? I use the, Noah? Molar mass. Is correct. So, what is the molar mass? 144 gram per mole. So, find the number of moles, which is
No.
Are you done swishing? Dylan's not here, and you're like, well, I'm just going to be the new swisher. And you just swish the whole time. Okay, so we have 34. That's wrong. What?
Yeah, man, same.
I'm not even on the right problem. There we go. That 3 doesn't even look like a 3. Okay, so we have. They don't even give me the number. What are we supposed to do with this? Okay, that's some number. Anyways, molarity or molality is number of moles divided by kilograms. So you will get 0.0198.
Sitting next to you is really
It
intriguing.
is like, it is an experience to be here.
What is
Right?
it? What did you do?
This is some number. So that is 0.00247. Divide that by 0.125. And you get that.
Wait,
Yeah.
is this a different problem or this is
That's
one?
A, this is B. 21B.
Oh, they're different problems.
Yep. So there they gave us moles, they gave us kilograms, we're done. Here they give us grams of both. So now we need moles of the solute divided by kilograms of the solvent. Now I assume it will give it more complexity. So now we have 500 grams. New problem. You ready? New problem. 500 grams of solution and 12 grams of sodium microfluorophosphate. Yeah,
What's after 500 grams is like SOL.
solution.
Also.
Sol.
Maybe
What are we on? 21? Okay, so, yes, 21C. So, to find molality, we still need moles of our solute divided by kilograms of solvent. So, I have 500 grams of solution, but I only have 498 grams of water. So this is our solute, or sorry, our solvent. So I want 0.498 kilograms of water. How many moles of sodium, blah, 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 blah?
Oh, it's not
It's not 500.
solution, I mean?
Right,
Ah,
it's solvent.
okay.
How do we get from grams to moles? Molar mass. So 12 divided by 144 is 0.083. So the molality is that divided by 0.498, which is 0.17 mole.
Repeat them 0.498.
Because we need kilograms and not grams.
Oh, okay.
Great question. Should I rip the Band-Aid? No, we'll do it. Okay. Now we begin chapter 13.
Wait, I'm like really good.
Just tell us the bad news.
No, I.
Do it, do it.
Bye, Risa.
Just go ahead.
I can walk Risa out.
Wait,
What's up?
Mr. Wood.
I don't want to be. I mean, I want to be here. I just would like to make sure she gets there safely.
Very thoughtful.
What's up?
So what were we finding in this one?
Molality in all of these.
Like,
Hold on, everybody. Andrew.
how did you get
That's for you to know and for us to find out about. Thank you. Molality is moles per kilogram. So this is moles by Risa of solute over kilograms of solvent. So to get the kilograms of solvent, I needed that I need moles of solute, which is that.
So why didn't you use the 498 grams?
Because I need kilograms.
Oh, so where'd you get the 144?
It's given in the problem. It's the molar mass of that. Good question. Okay, now we are on chapter 13. This is an exciting chapter. This actually learns you things about life.
Oh, I'm gonna get learned. You're gonna get learned.
Today is Thursday, which means tomorrow is Friday, so probably lab. So
Come
be
with a short
present.
sleeve.
What?
So bring your laptop.
But, are we gonna be working on our, like, science?
Camera?
fair stuff?
No, because science fair is done.
There's not.
I know.
Tomorrow's Camo Day, right?
I don't know. Read the email.
Yes, it is.
Turn my emails off.
Oh well, then
How do you-
ignore nothing.
You know how do you?
You go back into the settings and you turn them on in the opposite way. Wow, I'm such a jerk. All right, chapter 13. Thermodynamics. Thermo. Heat. Dynamic. Moving.
So moving heat.
Yes. How do you move heat? Okay. Dynamics is the study of moving things. Statics, the study of non-moving things. Okay, so we are on thermodynamics. So things that you should know that are important. Temperature, number one. These are like important things for you to remember. Temperature expresses the average kinetic energy in the particles of a sample. So, the higher the temperature, the more the particles are moving, because kinetics also has to do with motion. Okay? We've talked about this before. Fuentes will tell you all sorts of things about absolute zero, but the number one thing that she will tell you in her science fair experiment is that when you have no motion, your temperature should be 0 Kelvin. So it's a measurement of how much motion is going on there. Now, heat is something different. We often like to think of them as the same things. They're not. Okay? Heat measures the total amount of thermal energy transferred from one substance to another. Heat is measured in a number of different units. The most common one is the joule. Joule, which is a Newton meter. You know, when you have something looming over you, and you're like, ah.
Just tell us.
No, it's like looming.
Rip the
But
Band-Aid.
don't want to rip the Band-Aid.
Is that supposed to be like a
You're not
video?
supposed to keep
Is it like cat living the cat out of the bag? What does that mean?
Yeah.
Okay, so rip the Band-Aid.
No, I don't want to. Ah, okay.
You're hurting us by hurting
Yeah,
yourself.
I do. Rip
You're not
the
allowed to
Band-Aid.
keep
Just do it.
Let's put some Neosporin back on that thing.
Oh,
You put it back on for now.
Yeah.
Oh, people know, yeah. It's got like a little letter in it.
That's the Band-Aid?
Do it.
No.
Do it.
You're making me
I had a
No,
student,
yeah.
I had a student
Oh my
bust their nose on the corner of one of these. They were sitting down.
I know who it
And they
was.
went like, I do too.
Now I know who that was.
And so I made them wear a Band-Aid across their nose there.
This was
Oh, I got.
Band-Aid.
You said they got in a fight.
Rep the Band-Aid.
Oh yeah, I did tell them that I got in a fight and I won. But, alright, so, there we go.
Rep the
I
Band-Aid.
believe it.
Alright, so,
My gosh.
he is measured in joules.
Tell us.
Yeah. We're not gonna be able to focus.
I thought it was on.
Yeah.
I'm not gonna be here
Don't
tomorrow.
put 'em on.
Forget it.
If you're not gonna be here
Rip
tomorrow.
the band. Yeah, do it for
You
him.
gotta stay here to see the band.
Go for Noah.
Good for
Noah.
Noah, amazing. Good
Oh, he's
Wait,
colored.
what?
Look, Bill's crying on the floor right now.
for him. Crying on it.
Tell him.
Oh.
Do it, do it.
Rip the Band-Aid.
Right.
Wait.
Okay.
You can't.
Okay.
I am politely asking you.
Here's the Band-Aid.
No.
Yes.
This is more pain for you than it is for me.
I don't
It's
care.
no work for me.
I'd like to know now instead of 2 days before you want us to do it.
Okay. So in 2 days, I will need you to, no.
Transfer to
Saturday?
tomorrow.
We can't print the stupid science fair boards.
Okay.
Oh
So we have to do a trifold.
Okay.
no.
Because,
It's not like we haven't been doing it.
because the, okay, here's administrative life, okay? Ready?
What does that mean?
So here's happy administrator Belinda, and then he has like hair here, but not, and then like, but it's missing like the side, like this part.
No point now.
Okay, so like, he's all happy, and then, here's how this happens. Okay, you ready? Then, he meets with some other administrator, we'll call her swearing lady, and she has hair.
Her hair's curly though.
And then, we meet with some dude who has no hair.
Coach, what? What is
Mr. Franklin, Mr. Cotton.
So, this guy is really smart,
Oh, reserved away.
and he goes, here's how much the bathrooms are gonna cost.
Oh, I know you.
Is that?
Oh, is that the
So,
guy that was
and
out
then
there?
he gives this to these two. So now, in one hand, we have the bill for the bathrooms. I'll draw a toilet here, which is, you know, a bathroom. Okay, so, how do you draw a toilet?
You felt like.
I can do one for you. For box.
There we go.
It's like a tub.
So then you have like the toilet or the bathroom bill, right? And then Belinda comes in with the science fair board bill, which is $1,400.
Whoa.
And then Belinda's like, remember we said we were gonna pay for this? And then, but then both bills are in the same. And so then we go, do we want science fair boards that look good, or will we suffer? And then
Well.
we decided that, like, no.
Why don't we just print the best?
We don't
And
have
the
to.
I probably will.
Just project them.
We don't have to.
We don't have to do any boards at all. We're talking 8 kids. This is what we did.
So,
You want some key?
so the Band-Aid is ripped. So
Aw. I'm gonna go cry.
by next
now.
Friday, you need to bring in a trifold board.
So,
Yes.
you go to us, you were gonna give me
Wait,
the
we
idea
need
of
to bring
leaving
in,
tomorrow,
or we need
but
to have.
coming back, how
Yeah,
you
that's
finish
also
Sunday night, this board idea that you had online, and finish
Did
it
you already do
one
it?
night, and get it done tomorrow, so I can, the next day, so I can present it. to classes.
We're still gonna, you still have to do it.
Yeah, but
Wait.
it's not your Friday.
Oh, we
it's
don't have to
Friday
do
before,
the
because I've been
online
doing it
ones
for the
anymore
past
then?
6 years.
So what I want you to do is I want you to do your draft in Google Slides, and then I'll approve that, and then you do the printing.
Why don't we just print our own?
How much does it cost?
How much
Like
does it
$50.
cost? That's enough. Like,
Ridiculous.
that's not.
That's ridiculous.
Yeah,
That's
but
way too much.
$50 is like.
You get like a $2 board, and then you put like free, and you, so, that's the Band-Aid. I'm sorry, I tried, I wanted to do it, but
Every year.
apparently,
Something happens.
something happens every year. Apparently, the girls having 6 toilets and like a vanity mirror so that they can do their and like the little lights around
You
it.
guys are getting.
So can we get a vanity mirror?
Andrew, just for you, I'm gonna have like one of those Jetsons things where like you walk up to it and then you're like, you hit the button, it'll have 4 buttons. One of them will be for curly hair. And
Yeah.
then it'll get like the little curling iron
Yes,
out
we
of
need
it.
that.
And then it'll like,
Thank you.
okay, so here's what I need.
Wait, this one, can we get a cone?
Here's what I need from you. I'm sorry. I need you to bring in a tri-fold board by next Friday, a week from tomorrow. And I still want you to design it virtually so that I can see it and see if what you're doing is on track before you actually make the board. Okay, that is it. Yes?
Any size?
I will research an appropriate range of sizes.
The little ones. The tiny ones.
Yeah.
Good
dude,
question.
little
Yes.
marker.
So by next Friday, you want us to bring in a board?
A
or do you
blank
want us to-
Tri-fold board.
Does that have to be
It doesn't
white?
have to be done yet.
I want it to exist here.
Can it be neon yellow?
Okay.
White,
So it
yellow,
doesn't
neon
have to
yellow
be
board.
done yet.
Black. What do you want?
I want that.
Black.
Or neon green board?
Yes.
Or neon brown?
So I will post this in the classroom.
And then white is just like every little.
All right, the Band-Aid is ripped.
Oh my gosh, guys.
I thought you were gonna tell us that.
You know there's
That my wife's pregnant and I'm not gonna be here for the rest of the year.
Oh, what? Why would you
Wait,
know?
the email.
It's in the email.
It's on the classroom.
That's good. If you guys do find out, I'll put it in the weekly email. Okay, that's that. Back to important thing. I'm sorry. I tried. Alright, next year though, we'll just buy a commercial printer that print and then just do it, and then you'll be like, man, all those years that we had to do. A page this big. Oh, you just glue them together. Okay. So, I hate ripping Band-Aids. How much time do we have? Over 20 minutes.
5 seconds.
I was ready to be done.
Maybe we should do that as presentation after you eat it, because you just wanted it to be done.
No.
Yeah, why don't we take a walk?
Yes.
I'm gonna.
We understand.
Okay. That's the. Alright. So.
They're too spicy.
Jesus Christ.
All I gotta say.
My ears.
Okay, I have to get to a certain point so tomorrow's lab makes sense. So let me get to that point and then we'll talk. Okay, so there's this thing called enthalpy. Ugh. And its symbol is H, not its unit, but the symbol. It is the thermal energy constant of a system at constant pressure. Okay, so enthalpy is a different way to measure heat-ish. Okay, but specifically thermal energy. Generally, we will talk about a change in enthalpy, which is heat. Okay, there is a device that is called a calorimeter. It is an insulated container. Why is my handwriting so bad? Insulated container, like a thermos, in which the thermometer detects a temperature change.
Wait, what does the first word say?
Yeah.
Insulated.
I thought it was like insulated.
So here's the idea. You have this thing. It's called a calorimeter. In our experiments, we will use a styrofoam cup which isn't great, but it gets the job done. Okay? You put a thermometer in there. Okay? So now you can measure the temperature of whatever is happening inside this calorimeter. Then you do a reaction. So you put stuff in there that gives off heat or requires heat and absorbs heat. And you measure that change with the thermometer. Then you know, based on that chemical reaction, how much heat has been given off or how much heat has been required and absorbed in your reaction. So, calorimeter, good.
For FWP, is it thermal energy content?
Thermal energy content of a system at constant
That's an E?
pressure.
Or is that a U? Or is that an A? Or is that an N? Switch to cursive. Okay.
I don't read my notes. I write notes in cursive in meetings, so it looks like I'm showing honor to the people who are talking, but I have no intention to ever read them. All right, moving on. So there are two types of heat that you should know. Sensible heat is the heat that produces a temperature change in a substance when applied. And then there is latent heat. Latent heat is the heat that produces a phase change. Okay, so what are we actually talking about? Because these are all great words and everything, but we are going back to the exact same thing that we have covered like 50 times already in this class, and that is the following graph. Okay, so if we have, let's say, water, we warm the water, then it goes through its phase change. So we warm the ice, phase change, warm the liquid water, boils,